So this is the review on chapters 1, 2, 3, 4, and 5. Like I said, we will be having a final at the very end of the year, including these chapters and chapters from volume 2. So we are going to start with chapter 1. These problems come exactly from the makeup tests that we've been doing. So this one, find the greatest common factor, the GCF, of 21, 35, and 49. So I want you guys to do that on your paper. So the trick to solve for greatest common factors is you initially pick the smallest of the numbers given to you. You pick the smallest, and then you find the factors of that number. The first factors are 1 and 21. Who can tell me what the next pair of factors are, Trey? 3 and 7. Excellent. What we do now is we work our way down from biggest to smallest. Does 21 fit into 35? Does it?
No.
Like, as a factor, is 21? No, it does not. Now we check 7. Does 7 go into 35? Yeah, so that one works so far. Then we check it with the next one. Does 7 go into 49? Yeah. Since that was the biggest one, we started from biggest to smallest. That's our answer. If we started with a different one, we wouldn't necessarily be able to work. Yes, in this case, 49 would work because our only factors are 1 and 49 and 7 and 7. But this is an easy way when we have factors that don't necessarily work out as nicely as we would hope. We'll see that again in the next example. A gardener has 27 pansies and 36 daisies. She plants an equal number of each type of flower in each row. What is the greatest possible number of pansies in each row? So yet again, what we're going to do is we're going to pick the smaller of the two factors, or of the two multiples. We're going to pick the smaller of the two multiples. This should be obvious. Which is the smaller of the two multiples, Trey? 27. So we're going to do our 27. We find our factors of 27, 1 and 27. Who would like to tell me the next group of factors? The next group of factors. Yes, Daniel? 3 and 9. Is there any other ones?
Yeah. 3 and 3.
3 and 3? That makes 9.
What? 9 times 3.
So is there any other factors for this? No, there are no other factors. So now we think about it, we go again from the biggest to smallest. 27, is that a factor of 36? No, it is not. I see all the heads shaking. 9, is that a factor of 36?
Yes.
We see yes, it is. So, it is. So that means that the greatest number that we could plant in the row would be 9. Our answer would be 9. So these are pretty simple. My suggestion is always start with the smaller multiple, find the factors of that, and then start from biggest to smallest. That will help you determine if they have matching factors, if there is a GCF at all. And it's important when we get much larger numbers. This is really helpful when we get much larger numbers. So, our next one. Find and simplify the ratio of how many people like cats compared to the total amount of people. So we're going to look at this, and I want you to take time to solve this problem. And remember, we don't shout out answers. There's 2 ways to write a ratio. What's the first way that comes to your mind when you write a ratio, Miles? Something over something, not something over 1. Something over something. What's the other way that we can write a ratio? Who knows the other way? This is my favorite way, Hannah. Yeah, kind of like that. So we would write it, though, with 2 dots like that, with a colon between it. That's what it's called, a colon, not like inside our body. But, so, these are the 2 ways that we would write it. In this case, it would be cats to total, and here it would be cats to total. So those are the 2 ways that we could write our ratios. Now, these are simple. How many cats did people prefer? What was the answer for cats that people prefer, Romario? 8 cats. So we would write it like that. Now, this is trickier for people. What is the total number What is the total number?
52.
52. Nathan, how did you find the total?
I added them up.
You added them up. Total means add. Did you include cats in the total?
Yeah.
Yes, because that's part of the total amount of people. A lot of people forgot to add cats in, which made it wrong. Now, is this our answer?
No.
No. What do we have to do to make this our answer, Lucy? Simplify. This is the same thing. We're finding the greatest common factor. That's what simplifying is all about, finding greatest common factors. So if you don't know the greatest common factor, my suggestion is just divide. If they're both even, just keep dividing by 2 until you get to the end. But who happens to know the greatest common factor? Let's see, Trey. You don't know? Gore? 4 is the greatest common factor. What happens? I want to see fingers. What happens when we divide 8 by 4? Fingers up. I see 3 people's fingers up. There we go. Yes, it is 2. So the same thing would be here. And then what happens when we divide 52 by 4? Who can tell me? Who can tell me, Fernando? Yes, it's 13. It is 13. Once again, I want to teach you just a separate trick. It may make sense to some of you. It may not. I'm just going to show you really quickly. If I can't do the math in my head, I split 52 into numbers I know that I can divide. So for example, 52 is the same as 40 plus 12. That makes sense, right?
Yeah.
That makes sense. What's 40 divided by 4? What's 40 divided by 4? We get 10. What's 12 divided by 4? We get 3. So we add those together and we get 13. So that's another way that you can look about this. Okay. Those are the 2 ways that we can write it. We can either write it as 2 over 13 or 2 colon 13. Both ways are ways that you'll see ratios. So don't be afraid if you see either way. You have to know that they can be written either way. Okay. Same thing here, we're doing 2 problems. This is the first one. Find the equivalent fraction. So in this case, we have 4 over 5 equals 28 over something. How do we do this problem? Who can tell me how we do it? Michelle?
You have to see how many times 4 goes into 28.
Perfect. We see how many times 4 goes into 28. Whenever we do this, we draw the arrows to the unknown. So do you see how we draw the arrows to the unknown? That's how we do this. So how many times does 4 go into 28, Lucy? 7 times. So what we do to the top, what do we say?
We do the bottom.
We do to the bottom. So what's 5 times 7? Raising our hands. I'm going to see Trey.
35.
35. So our answer is 35. There we go. That's it. Now, for the next one, the results of a car race are shown. Who was the fastest? This was tricky for almost everybody. So the first one, we see A. He did 35 laps and it took him 84 seconds. For B, he did 42 laps and it took him 96.6 seconds. Lastly, C did 38 laps and it took him 102.6 seconds. Now, this problem, we have a trick way to do it, but it won't always be like that. Let's look at this. B had 42 laps, and C had 38 laps. Who had more laps, B or C? Who had more laps, B or C? Let's see. B, we said B. And who had more time? Who took more time to do it, raising our hands? Let's see, Hannah. C. So if B had more laps and took less time, do you think C's going to be the fastest? No. So we can automatically cancel that one out because we know that just doesn't work. Then what we would do is we already set it up into a ratio form. We want to simplify as best as we can. So let's take some time to do that. Here's the easiest way to do it. 35 and 84, those don't have anything in common. We can't really divide by that. 42 and 96.6, that's hard. But what we can do is we can set these two equal to each other and then see which one is less. So What do 35 and 42? What's their greatest common factor, Daniel? Their greatest common factor is 7. Exactly. So we're going to set them up into ratios of 7. So for A, it becomes 7 over something. We'll get there in a second. And for B, it becomes 7 over something. What did we divide A by to get 7? What did we divide A by to get 7? Who can tell me? Trey.
5.
We divided by 5, so we're going to divide 84 by 5. What did we divide B by to get to 7, Lucy? 6, so we're going to divide 96.6 by 6. So do that on your paper. When we divide 96.6 by 6, we get 16.1. Who has 84 divided by 5? Gore, what is 84 divided by 5? 16.8. So, which one was faster? Who can tell me which one was faster, Trey?
B.
B is faster. B is faster. Devin wrote the rate 108 in 6 weeks as a unit rate. Find her mistake and correct it. So I wrote 108 over 6, and my unit rate was 54 over 3. What's my mistake, Michelle? A unit rate has to have 1 on the denominator. That's the mistake. So what would our correct answer be? How do we get from 3 to 1? We do what?
Divide by 3.
We divide by 3, so we do the same to the top. We divide by 3, and what do we get? 54 divided by 3. Take your time. Romario, what's our answer? 18. So our unit rate would be 18 over 1. A lot of you guys said she needs to flip it or she needs to do stuff like that. No, the only thing is when we're dealing with unit rate, it must be over 1. Again, let's look at this one. Write the unit rate. 162 water bottles in 9 cases. How would we set this problem up? 162 water bottles in 9 cases. How do I set that up, Lucy? I do what? Yep, 162 over 9. Now, we know that the only factors of 9 are 3 and 3 and 9 and 1. So, try those. And we know it has to be a unit rate, so we know it has to be over 1. What's the answer, Lucy? It's what? 18 over 1. Exactly, 18 over 1. That's our unit rate. Once again, if you didn't know how to do this, you can split it or you can do long division. Next one that we're doing, we have 2 more. Complete the ratio table. Everybody should be able to complete this ratio table. Now, the easiest way, there's many ways to complete this unit table that I saw. A lot of them were pretty genius. We're going to just do the most simple way. What is the greatest common factor that 16 and 12 have in common? What's the greatest common factor, Rafi? That is not the greatest common factor. 8 is not the greatest. Rocco? 4 is the greatest common factor. So, how do we go from 16 to 4? What do we do, Michelle? Divide by 4. And then how do we go from 4 to 12? How do we go from 4 to 12, Malia? Times 3. What we do to the top?
We do the bottom side.
Exactly. So, what's 80 divided by 4? Who can tell me? Let's see. Romario. 20. And then, what's 20 times 3, Miles?
60.
Excellent. Congratulations. You guys just finished the ratio table. The last one, I want you to correct the error. Let's see. We have to correct this ratio table. What do you think the person was thinking when they made these errors? What do we think, Gore?
They were subtracting and adding.
Yeah, they were doing subtraction and addition. So they did -1 here and then plus 14 here. And we see that same thing, -1 here, plus 14 here. When we do ratio tables, do we do addition and subtraction?
No.
No, we do not. We have to do multiplication and division. So, how do we get from 2 to 1? What do? We divide by 2. And then how do we get from 1 to 15? Trey?
Multiply by 15.
Easy. So, what is 6? I want everyone to call it out at the same time. 6 divided by 2 is?
3.
And what is 3 times 15? Call it out at the same time.
45.
Excellent. That is the answer. Let's look. Okay. Celine earns $25 an hour tutoring. I want you to complete the chart, and on the next page, we have the graph. Gloria is going to be our teacher right now. So she's going to fill out the chart accurately. Let's watch. Check to make sure you did it.
I feel like I'm...
Excellent. Who agrees with her work? Raise your hand. Look at that. That's basically the entire class. And if you aren't, then you're wrong because this is correct. Excellent. Gloria did great work. Now I want to ask you, what is an ordered pair?
Okay.
What is an ordered pair, Hannah?
An ordered pair is it's mainly used with charts.
Yeah, it's used for charts. So in the first ordered pair, if we look at it, when we do it, it's got X's and Y's. Which one comes first, the X or the Y? Trey?
The Y.
The Y comes first? Who agrees? No, what comes first, Romario? The X comes first and then the Y. We can remember that because it is alphabetical order. X, Y, and then Z, which we don't deal with until much later. So, here would be the graph. So if we did this graph, and if we did it a little bit better than I drew it, we have 1 and 25. We have 4 and 100. We have 5 and 125. We have 7 and 175. And we have 9 and we have 225. Hey, what does that make? What does that make, Adriana? Yeah, it makes pretty much a straight line, more or less. My graph is off because I hand drew it. But it makes a straight line. If you have a graph, if you're graphing this and you're getting points like this, then you know that there's something up. All of these, it's a ratio, make a straight line. Okay, next 3. Determine if each ratio is equivalent. Once again, you set them equal to ratios and see if you can get them equal to one another. Do that on a separate sheet of paper. One thing we want to do, the easiest way is get our denominators equal. 3 and 5. What is the greatest common factor between 3 and 5? Trey? No, Romario, what's the greatest common factor? 1. So we have to divide to get them to be 1. So we divide this by 3 and this by 5. This next one, who happens to know what the greatest common factor between 45 and 135 is? Do we know? Daniel? Who knows? What do we think, Gore? 15's a really good guess. We could even use 15 for this. It actually is 45. Now, even if you don't know the greatest common factor, just keep simplifying until you get the same denominator. There's nothing wrong with that. And similarly, the greatest common factor of 28 and 560 is actually 28. But like I said, if you don't know it, just start dividing. If they're even, divide by 2. If they're end with a 5, divide by 5. Do whatever is the easiest way for you. It doesn't matter unless you're doing what's easy. So simplify and answer if the first one is equal, second one is equal, third one is equal. They should be yes or no answers. What's 96 divided by 3? What's 96 divided by 3, Daniel? You forgot? What's 96 divided by 3, Trey?
36.
Not 30. Yes, 32. What is 160 divided by 5? What's 160 divided by 5? Does anybody know? What do we think, Trey?
32.
32. So, is this first one, are they equivalent?
Yes.
Yes. So the first one is equivalent. Now let's look at the second one. We'll look at the second one. Now, once again, we could divide by whatever we want. In this case, it's easier to just keep the bottoms at 45. So, now, how do we get 135 to equal 45? How do we get 135 to equal 45? Who can tell me? Lucy? Divided by 3. So we get 45 here, we get 45 here. This stays the same as 15. And what's 45 divided by 3? 45 divided by 3. Who else can tell me? Yes, Rafi? 15. Are these two equivalent?
Yeah.
Yes. Last one. So we're going to check our last one. Now, I already told you that we can get them to equal 28. Like I said, it doesn't matter how you do it on your test as long as you're doing the right thing. We can do 28 and 28. What do we divide 560 by to get 28? The hint by that is to divide 560 by 28, and whatever your answer is how you can make it into 28. So what is 560 divided by 28? I'm really impressed. What do you think the answer is, Gore? 20. So we divided it by 20, right? So what is 240 divided by 20? What's 240 divided by 20, Lucy? It is 12. Yes. Is 16 28ths equal to 12 28ths? No. So that one is not equal. It is yes, yes, no. Exactly. Yes, yes, no. In 10 minutes, a heart can beat 700 times. Our initial ratio would be 10 over 700. Really easy. We want to find out how many times it beats in 140 minutes, or 140 times, and then how many minutes it takes to beat 630 times. Here's the easiest way. Let's simplify this first fraction. 10 over 700. Or how can I simplify 10 over 700, Michelle? Divide by 10. Just cross off my zeros. I get 1 over 70. Excellent. How do I go from 70 to 140? What do I do? Rocco? Times 2. So 1 times 2 is 2. So our answer here is 2 minutes. Next, again, let's look at this 70 to 630. How do I get from 70 to 630? It's the same as going from 7 to 63. Rafi? By 9. So what do I multiply the 1 by? I multiply it by 9 and I get 9. So this answer right here is 9. That's the easiest way to do these ratios. It's super duper easy. Okay. The table shows, this was really hard for a lot of you. The table shows people's favorite subject. How many students out of 400 like math? So we need to set up our initial ratio, and then we need to get it out of 400. So find the initial ratio for me. Lucy, what's our initial ratio? 6 to 20. Exactly. 6 students like math, 20 students total. This is easy. How do we go from 20 to 400? Jaden? Times 20. So we do the exact same to the 6. What's 6 times 20? Who can tell me? Miles? 120. And our answer is then 120. Exactly. So a lot of people messed up on this one because you did not read. What is the least common multiple of 6 and 9? Multiple, not factor. Multiple, not factor. Yes. What is it, Michelle? No, multiple, not factor. Gloria. It is 18. So we get our answer to be 18. Here's how we do it. We have 9. Then it becomes 18, 27, 36. We have 6, 12, 18, 24. Hey, look at that. Least common multiple? 18. Pay attention to the words. Least common multiple. Okay, these ones are easy. We write the ratio as a fraction. I want you guys to count this, okay? I want you guys to count the hearts and count the sad faces and all of that. I'll make it easy for you so you can see. We're going to do A first. What's the initial fraction? AKA, how many stars are in the initial fraction? How many stars, Daniel? 2 stars. How many hearts are in the initial fraction, Daniel, again? No. How many stars? Or
Eight.
how many hearts? What do we have, Nathan? 8. Is that our answer?
No.
We have to simplify. Lucy, what's the simplified fraction? 1/4. And if we explained it, what it means is 1 star for every 4 hearts. Next one. Let's look at this next one. We have the smiley faces to frowny faces. How many smiley faces do we have? Who can tell me how many smiley faces we have, Gore? We have 10 smiley faces. How many sad faces do we have? How many sad faces, Rafi? 6. Is that our answer? Is this our answer?
No.
What do we have to do? We have to? What is the simplification of this, Miles? 5 and 3. What that means is we get 5 happies for every 3 sads. Exactly. 5 happies for every 3 sads. You had to explain it. You had to tell me what it meant. You could write it in either direction. You could have written 3 to 5 as long as you explain what it is. 4 students spent $12 on a school lunch. What's the initial ratio? 4 students spent $12. Initial ratio? I want to see the initial ratio. Matthew. 4 to 12. Can I simplify that?
Yes.
What do I get, Trey?
1/3.
1 to 3. Exactly. It says at this rate, how much would 10 students spend total? If this is my students and this is my money, we want to get to 10. How do I get to 10 from 1? I multiply by 10. So I do the same on the other side. What's the answer? 30. The answer is simply as easy as 30. Exactly. This one's tricky. This is a tricky one. Jersey Mike's made 27 sandwiches using 12 pounds of turkey. What's the initial ratio? What's the initial ratio, Hannah? 27 to 12. How much turkey was on each sandwich? How much turkey was on each sandwich? If I want each sandwich, what does each mean? What does each mean, Romario? 1. It means 1. How do I go from 27 to 1? I do what? Divide by 27. I'm going to do the same thing here. 12 divided by 27. We look for our greatest common factor. What is the greatest common factor between 12 and 27, Lucy? 3. What is 12 divided by 3? Who can tell me? What is it, Daniel? 4. What is 27 divided by 3? Who can tell me? Trey. 9. So guess what our answer is? 4/9. That's our answer. Our answer is 4/9 of a pound. Great job, you guys. We completed test number 1. Tomorrow we will be doing test 2. So today we will be going over our chapter 2 review. So for chapter 2, our first 3 questions, write each decimal as a fraction or as a mixed number in simplest form. One of the biggest problems we had was that people did not write these in simplest form. Whenever we have a problem, you always simplify. Unless it asks you to find equivalent ratios, in which case you won't be simplifying. Every other time you will be simplifying. So I want you to do this in your notebooks, and then we'll go over how to do it. Like I said, these problems, doing the 3 of them should take you no longer than about a minute. The first problem will take you about 3 seconds. Who can tell me what place value that is in, Hannah? That's in the tenths. So the answer is 3/10. That's it. That's it. What about this one? What place value is the furthest number in, Rocco? The hundredths place. So we write 65/100. But is that the answer? No. We have to simplify it. When we simplify it, what do we get, Rafi? 13/20. Once again, we find the greatest common factor. It is 5. Even if you didn't know the greatest common factor, they both end in a 5 or 0. Just start dividing by things. Lastly, here's the cheat method for this one. We already know it's going to be a mixed number. So we know it's going to be 9 and something over something. You don't even need to do anything with that first number. It's 9 and something over something. What place value is this in, Nathan?
100.
It's in the hundredths. So then it's going to be 35 over 100. Is that our answer? No, we need to simplify. What do we get? 9 and what? What do we get? Let's see, Lucy. 7/20ths, exactly. Once again, our GCF is 5. Even if you didn't know that, you can see they're both divisible by 5. Just go. See how that took us about a minute? Exactly. So Hannah came up with a great example. You can multiply until you get something that's over 1, over 10, over 100, over any sort of thing like that. And then we just move the decimal back. Let's say that we had 756 over 100. To make it a decimal, we just move it back until it's over 1. So we move it back, and our decimal would be 7.56. That easy for that. I want you to try this. Another way you can do it is long divide. Those are the two ways. So as Hannah so brilliantly said, we can make it something over 1, 10, 100,000. What are we going to make this one over? What are we going to make this one over, Jenna? We're going to make it over 100. How do we get from 25 to 100, Nathan?
Times 4.
Times 4. What we do to the bottom?
We do to the top.
Excellent. What is 19 times 4, Trey?
177. What?
19 times
76.
76. Now, so what we do now is we want to get our decimal over 1. When we get something over 1, that's just our answer. So we have to move our decimal. 1, 2. We do the same to the top. We did that. 1, 2. So our answer becomes 0.76. Congratulations. We did that problem. So Trey said we can divide it by 5 to get 100. That's a good thing. But is 311 divisible by 5? No. So we're not going to do that. What can we do instead? What can we do instead, Fernando? Multiply by 2. We get 1,000. And what do we get at the top? Hannah? 622. Once again, we bring our fraction, or we bring our decimal over 1, 2, 3. 1, 2, 3. We get 0.622. Excellent. I'm going to skip to D because it stays along with the same thing. We get 14 and 3/5. If we're writing it as a decimal, we already know it's going to be 14 point something. 14 point something. Whenever we have our big number, it stays the same. We have our integer, it stays the same. 3/5. 3/5. What can we make that into that's nice and easy? What can we make it into, Nathan? 10. How do we get from 5 to 10? What do we do? Hands, fingers up. How many times? 2. So what do we get for the top number? Who can tell me? Liam.
Top number?
Yep. For a numerator, what does it become? 6, exactly. Thank you, Daniel. So we get 6. We move it over 1 time here. We move it over 1 time here. Our answer becomes 14.6. Super easy. Now, with our last one, we have a little bit more difficulty, but really it's not that much because I'm telling you the easiest way to do these. For this one, we have 5/8. Can 8 really multiply to anything that's going to be helpful? 10, 100,000? No, it can't. So we're going to long divide. Which number is our divisor? Who can tell me which number is our divisor? Rafi? I believe that it is not. What number is our divisor, Miles? 5. And I think 8 is the dividend. Am I correct on this?
Yes.
Yeah? Okay. I'm not quite sure. So let's find our quotient. Now, we already know that it's going to be 0 point something because 5 is less than 8. So we already know that. We bring our decimal. How many times does 8 go into 50? Who can tell me, Fernando? 6 times, exactly. And what is that? Who can tell me? Michelle? What's 6 times 8? 48. So we get 2. We bring down our next 0. How many times does 8 go into 20? Who can tell me, Romario? How many times does 8 go into 20? 2 times. And that's 16. We have 4. We bring down our last 0. Emerson, how many times does 8 go into 40? 5 times. And it is exactly 40. So there we are, done. And look, we're already in decimal form. So we get 0.625 or 625 thousandths. This is very, very easy. What percent of the days are sunny? How do we find percent? Percent is something over what, Nathan? Percent is something over 100. So to get Sunny, how do we get from 25 to 100? Times what, Romario? 25 to 100 times what? Times 4. So we do the same to the top. What's 11 times 4, Madison?
11 times 4 is 44.
Perfect. 44. So 44% of the days are sunny. Next, what percent of the days were rainy? It's the exact same thing that we're doing. What percent of the days were rainy? We multiply 25 times 4, so we do the same to the top. Malia, what's 4 times 4? 16. Exactly. Now this is super easy. Ready? This next one. What percent of the days were sunny or rainy? We already did both of these. How do we do this? What percent of the days were sunny or rainy, Trey?
Sunny and rainy was 60.
60. How do we find that, Hannah?
We added.
You add. That's it. You added 44 and 16. Now lastly, what percent were cloudy or partly cloudy? If we have both of them, this is the easiest way to do it. We'll add them together. What do we get when we add 1/10 and 3/10? What do we get, Rocco? We get 4/10. And then we need to make it over what? What do we need to make it over, Trey? 100. How do we get that? We multiply it times
10.
Yeah, 10. So what is 4 times 10?
40.
Excellent. 40. So the answer is 40%. You see how easy these problems are when you remember the tricks?
Yes.
I'm not sure why I made the graph. I forgot I took a picture of it on the other page, but I did it prettily anyway. So, next question. Write each percent as a fraction in simplest form. This should be really, really easy. What is a percent always over? What is a percent always over, Daniel? Over 100. So we get 14 over 100. We get 47 over 100. And we get 88 over 100. Excellent. Now, 47 over 100. Can we simplify that? No. So that is just 47 over 100. But we can simplify the other two. Do that on your paper. 14 and 100. What can we divide them both by? We divide them both by, Daniel? 2. So we get 7 over 50. Can we get any smaller? No, that's our answer. What about 88 over 100? What can we divide them both by? What's the greatest common factor? Who knows, Romario? You can divide them by 2 and we can just keep working. We would get 44 over 50. Can we divide it by anything else, Adriana? 4. So if we divided it by 4, what is 88 divided by 4? Who can tell me 88 divided by 4? Rocco? 22. And what's 100 divided by 4? Everyone should know this, Fernando? 25. So look at that. This problem took about 2 minutes maybe. So you're going to write each percent as a decimal and as a mixed number or fraction in simplest form. A decimal or a mixed number or fraction. I'm going to give you a hint. When we have a percent over 300, we know, or over 100 I mean, we know that our initial thing is going to be 3 point something, and it's going to be 3 and some fraction. Same thing here with the 480. It's going to be 4 point something and 4 and something over something. Whenever we have over 100%, that's simply how it works. As opposed to when we have under 100%, it's going to be 0 point something and just a fraction. 0 point something and just a fraction. We do the exact same thing. Put it over the furthest place to the right. Put it over the furthest place to the right. So you guys should all do this right now. Who remembers the trick way that we can make a percent into a decimal? Remember? Who remembers, Fernando? Yes, we move it 2 places away from the percent. Here's our 1. We have our 1, 2. So we move it 1, 2. So as our decimal, we're going to get 3.5. Exactly. 3.5. That's as a decimal, so we get 5. That's going to be what place is that? What place is that? Anita, what place is that 0.5 in? Yes, it is the 10th place. We get 5 over 10. But is that going to be our answer? No! We need to simplify. 5 over 10 simplifies to what? Don't shout out, Trey, but yes, it is 1/2. So we get 3.5 and we get 3 1/2. Exactly. So I want you to continue and do the same for all of them. As Fernando so acutely said, to make something into a decimal, all you do is you move it over 2 times away from the percentage sign. So we move it, for this case, we move it 1, 2. So we get 0.0005, right? 0.0005. Oops, that's in the wrong box, but that's fine. 0.0005. What place is that 5 in? What place is that 5 in, Trey? It is not in the thousands. Good guess, Michelle. 10,000. So we get 5 over 10,000. What is their greatest common factor? 5. We divide them both by 5. We get 1 over. What's 10,000 divided by 5, Michelle? 2,000. And that's our answer. 1 over 2,000. Excellent. C is incredibly similar. It's incredibly similar. We move it over 1, 2. We get 0.0055. Once again, we're in the 10,000s place. So we get 5 over 10,000. What's the greatest common factor they have in common, Daniel? 5. So we get, what's 55 divided by 5?
11.
We get 11. And then we already did it before, over 2,000. 11 over 2,000. The last one, this one, for our decimal, 480%, right? We move our decimal over, 1, 2. We get 4.8, exactly. And as such, what place value is our 8 in, Emerson? What place value is it in? The tenths. We get 8 over 10. We need to simplify. When we simplify this, what do we get, Gohar? Yes, Gohar, we get 4/5. So we get 4 4/5. Excellent. Make sure you have this down. We are moving on. Write each mixed number or decimal as a percent. This is easy. We already know as a percent, if it's more than 100, if it's more than 1, it's going to start with whatever the big number is. So we already know that it's going to be 4 something and 2 something. In this case, it's not. Fernando, what's the trick when going to make a decimal into a percent? What do? We move it 2 times towards the percent sign. 1, 2. So this is 0.15%. Can we have percents less than 1? Or yeah. Can we have percents less than anything like that? They're numbers. They can be anything. As such, we have 2.64. 2.64. We move it over twice towards the percent. We get 264%. Last one that's difficult is 4 1/5. 4 1/5. We need to make that into a decimal. What is 1/5 as a decimal? This is something you might have memorized, or you can do the multiplication. Miles? Not 10 tenths. That means 1. What do we get, Hannah? We do get 2 tenths. And if it's 2 tenths, what do we get as our answer? It's going to be, Gore? 0.2. Exactly. 2 tenths means 0.2. We move it over. 1, 2. We get 420%. Excellent. As a decimal, same thing. We move it away from the percent sign. 1, 2. We get 0.003. To make this next one a percent, we move it 1, 2. We get 824.5%. Excellent. Here's the other thing. As a fraction, we already know what it's going to be. What is the 3 in? What place value is that 3 in? Who can tell me what place value is the 3 in, Romario? Thousandths. So we get 3 over 1,000. Is that our answer? Is that our answer?
No.
Can we
Yes.
Yes, it is. We can't simplify it. As such, what place value is this decimal in here? We're going to get 8 and some fraction. What place value is that last digit in? Everybody should know. What place value is that last digit in, Andrew? As Andrew said, it's in the thousandths place. So we get 245 out of 1,000. However, we need to simplify that. What can we divide them both by? What's the first number that comes to your head?
63.
What is that, Hannah? 5. I don't know what the greatest common factor is. Let's divide it by 5, right? So 1,000 divided by 5 is 200. What's 200 divided by 5? 200 divided by 5, Daniel? 40. So we have 40. And what's 45 divided by 5? Who can tell me 45 divided? Gore? 9. So our answer becomes 49. So we get 8 and 49 over 200. Exactly. Last one. I made this super easy. On a previous slide, we already divided 5/8. What is 5/8 as a decimal when we saw it earlier, Gore? Perfect. 0.625. Then we just need to make it into a percent. Remember, we move it towards the percent. 1, 2. We get 62.5%. You see how quick this problem is when we know what we're doing?
Yeah.
Exactly. You should have this first one memorized. What is 1/4 as a decimal? What is 1/4 as a decimal, Rafi? 0.25. Which is bigger, 0.25 or 0.4? What is it, Hannah? Perfect. Already solved. This next one, 7/8 and 5/6. Let's just butterfly math this. What's 7 times 6? 7 times 6 is? What do we get, Adriana? We get 42. Then what is 8 times 5? Who can tell me 8 times 5? Daniel? We get 40. Which one's bigger? Which one's bigger, Madison? 42. So we eat that one. Now, 2.3 and 2 3/10. We should know this. 2.3 is what as a fraction? 2.3 is what as a fraction? Trey.
3 over 10.
Yeah, 2 and 3 over 10. So which is bigger, 2 and 3 over 10 or 2 and 3 over 10? What? Exactly, they are equal. Last one, here's the trick. We have 0.7 and we have 7/9. 0.7, what is that as a fraction? What is that as a fraction, Matthew? It is 7/10. Let's look at this. 7/10 and 7/9. Which is bigger? 7/10 or 7/9, Lily? 7/9 is bigger because when the denominator is smaller, our fraction is bigger. We're going to come back to number 9. First, we're going to go to 10. A store is having a sale where winter clothes are 60% off the original price. A sweater is on sale for $30. What is the original price of the sweater? So we set it up like this. We know our percents are always over 100. So we have 60 over 100. And our price is the part. So it goes on top, correct? It's part. How do we go from 60 to 30? What do we do, Trey? 60 to 30, we divide by 2. So we do the same thing on this side. Divide by 2. What's the answer, Rafi? 50. Now our answer is not 30 over 50 because we're trying to find this. So our answer is 50. Exactly. Now we're going to look back at this previous problem. We have 6% of 95. That means 6 over 100 is equal to, here's the trick to remember. It is over of. So we get this. It says of 95, so 95 is on the bottom. We want to get what's on the top. So the easiest way to do this one is to make it into a decimal and multiply. What is 6 over 100 as a decimal? Who can tell me, Hannah?
0.0.
Perfect. It is 0.06. And we're going to multiply that times 95. I'm going to put this 95 on the top. When we multiply, we bring it over here. And then at the end, we bring it back the same amount of times. What is 6 times 5, Romario?
6 times 5 is
30, 0, 3. What is 6 times 9, Alinza? What is it, Miles?
54.
It is 54. So we have 54, but we have to add that 3, so we get 57. We move our decimal back, we get 5.7. That's our answer. Next problem, it's the same thing. Let's make it into a decimal. 15% as a decimal. What is 15% as a decimal? 15%, Lucy? It is 15 hundredths, 0.15, exactly. And we're multiplying that times 110. We move it over. At the end, we're going to move it back twice. This is easy. 5 times 0 is 0. 5 times 1 is 5. 5 times 1 is 5. We put our magic 0. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. We add them together. We get 0, 5, 6, 1. We move it back twice. We get 16.5. Exactly. What is 102% as a decimal, Fernando? Perfect. We get 1.02, and we're multiplying that times 750. Remember, when we multiply, we always line up on the far right. So we have to move our decimal over 1, 2 places. So in the end, we're going to move it back 1, 2 places. So let's start. 2 times 0, 0. 2 times 5, 10. 2 times 7, 14 makes it 15. Magic 0. But here's the thing, it doesn't even matter because we've got all of this is going to be 0. 0 times 0, 0 times 5, 0 times 7. So I'm just going to skip that and add our second magic 0 for the next one. 1 times 0, 0. 1 times 5, 5. 1 times 7, 7. We add them together. 0, 0, 5, 6, 7. We move our decimal back 1, 2. We get our answer to be 765. Exactly. Lastly, I want to see Gloria. What is 0.03 as a decimal?
0.00.
Perfect. It's going to be 0.0003. We're going to line that up with 1500. In the end, we move it 1, 2, 3, 4. So in the end, we're going to move it back. 1, 2, 3, 4. Okay. This is easy. 3 times 0, we get 0. 3 times 0, 0. 3 times 5, 15. 3 times 1 is 3. We put a 4 there. We move it all the way back. We get 1, 2, 3, 4. Our answer is 0.45 or 45 hundredths. Fernando calculates that he spends 15% of his school day in math class. That means it's 15 over 100. If he spends 75 minutes in math class, how many minutes does he spend in school? Is 75 our part or our whole? Raise our hand. Part or whole, Michelle? Part. How do I get from 15 to 75? Who can tell me? What do we do? What do we do, Gore? Times 5. What's 100 times 5? What is it, Trey? 500. So he spends 500 minutes in school. Action movies make up 85% of Emmett's movie collection. If he has 20 movies, how many action movies are in his collection? Is 20 the part or the whole, Nathan?
The part.
Who thinks it's the part? Raise our hands.
Wait, what?
Who thinks it's the whole? Raise our hands. It is the whole because he has 20 movies. How do we get from 100 to 20? What do we do? Rafi?
Divided by 5.
So we're going to do the same to 85. Who can tell me what 85 divided by 5 is? 85 divided by 5, Romario? What is it, Gore? It is 17. Once again, you could just do long division. We're just doing it quickly. So he has 17 action movies. If Devin has 3 cups of pineapple juice, how many total cups of punch can she make? Now, I have 3 cups. Is that the part or is that the whole? Raise your hand, Trey. It is not the whole, it is the part. We know that because it says total cups, total is whole. We don't know what it is. Now, pineapple juice. What's the percent of pineapple juice? What is it? 20 over 100. We can't do this very easily at first, 20 to 3, so we have to simplify. 20 over 100. What is 20 over 100 simplified? 20 over 100 simplified, Michelle. 1/5. How do we go from 1 to 3? What do we do? Liam? 1 to 3 is times 3. So we do the same to the bottom. What's 5 times 3, Rafi? 15. So I can make 15 cups of punch. How many cups of sorbet are used in 8 cups of punch? Is 8 going to be our part or our whole? Madison, 8 is our part or whole? 8 is the whole because it's 8 cups of punch. Sorbet. What is the percent of sorbet? What is the percent of sorbet? Melanie, what's the percent of sorbet? 15. So we get 15 over 100. Again, we can't do this one very well, so we have to simplify. You can't do this very well, so we have to simplify. Gore, what do we get?
3/20.
We get 3/20. It's still not great, but 3/20 is equal to something over 8. So what we do is we cross multiply. We get 20x is equal to 24. We divide by 20 to get our x alone. We isolate that variable. X is equal to 24 over 4. That simplifies to 1 4/20, which then simplifies to 1 1/5, which is 1.2. Exactly. Today we will start doing chapter 3 review. So chapter 3 is mostly about decimals, adding, subtracting, multiplying, and dividing. Let's look at these 4 problems first. We have 4.9 plus 3. When we set up this problem, how is it going to look? Like this? Or like this? So what do we think? Who thinks first one? Raise your hand. Who thinks second one? Raise your hand. Those of you who think second one, you are correct. When you add and subtract decimals, and I suggest you write this down, when you add and subtract decimals, you have to line up the decimal. When you add and subtract decimals, you have to line up the decimal. So in this case, the answer would be 7.9. I saw many of you students putting 5.2 as the answer, which is not true. That's if you didn't line up the decimal. So I want you to do it with the other problems, and then we'll see what answers we get. Okay, Gohar, what's the first step? What do we do? So we're going to first add the 6 plus 3. What do we get? 9. Oops, I'm using the wrong pencil. 9. We do that again. We get 9. What's 5 plus 4? 9. And then what's 1 plus 2? 3. And we just carry down that decimal. That just follows us right down. Okay, Alinza, what about the second one? Technically number 3. So we have to regroup with this bottom one because 0.39 cannot subtract 0.4. So we turn this into a 10. So we turn this into a 2. 10 minus 0. Oops, never mind. We did that one fine. We could do the 9 minus 0. We get 9. 3 minus 4. We turn that into a 13. And this into a 3, as I'm already messing up. 13 minus 4 makes it a 9. We just drop our decimal down. 13 minus 12 is 1. So we get 39.99 for number 2 and 1.99 for number 3. Now, this last one is a little different. We have multiplication. So when we multiply it, how do we set up our decimals then? How does it matter? Who can tell me how we set up our decimals when we multiply? What do we think, Miles? Same way we always did? That's a good guess. Does anybody have any idea? Madison?
The decimals don't have to line up.
Exactly. With multiplication, the decimals don't have to line up, Madison. So when we set them, what we do is we put them all the way to the right side. We did that in the last one as well. So when we do that, we just move our decimals however many places over, and then at the end, however many places back. So what's 8 times 4? Who can tell me, Michelle? 32. Put the 2 here, 3 here. What's 8 times 2, Emerson? Perfect. So it becomes 19. We get our answer to be 19.2. Who agrees with that? We give it a thumbs up? Yeah, we give it a nice thumbs up. Now here's technically number 4. It made more sense when looking at the test on paper. So the melting point of sodium is 97.8 degrees. So we think that's a pretty important fact we got right there. The melting point of potassium is that many. How much higher is the melting point of sodium? When we read that question, how much higher, what kind of operation might we be doing, Michelle? Subtraction, exactly. We're trying to find the difference. How much higher is the Empire State Building? We're trying to find the difference. So we have 97.8 and we have 63.65. How should I line these two up? Where is it going to go? How do I line them up, Liam?
Wait till because you'll put 97.8 under 63, but you would have to add 0 to behind the 8.
Yes, although we do put the 63 at the bottom because we are subtracting it, but correct, we put that 0 there so that they all line up. We're subtracting. 0 minus 5, can we do that? 0 minus 5? No, so we got to regroup. We do all of our regrouping. Woo! Regrouping, fun. Excellent. We get 34.15 as our answer. That's why this one was number 4 before number 5, because 5 started our multiplication section. So, for number 6, we have 0.0198 times 75. Now, this one's an interesting problem. It relates to what we've already learned, percents and numbers less than 100% and greater than 100%. Is this first number less than 1 or greater than 1? Less than 1. So are we going to get a number less than 75 or more than 75? Less than 75. When we multiply 75 by 1, we get 75. When we multiply 75 by a number bigger than 1, we get a number bigger than 75. For example, 75 times 2 is 150, bigger. So when we multiply something by a number less than 1, it's going to result in a smaller number. Once again, all we got to do, we're going to line them up to the far right side. It's easier to always put the one that has the most numbers on the top, just in general. And we know that we moved it over 1, 2, 3, 4, so in the end we will move it back 4 places. 5 times 8, 40. 5 times 9, 45, plus 4 is 49. 5 times 1 is 5, plus 4 is 9. Magic 0. 7 times 8 is 56. 7 times 9 is 63, plus 5 is 68. 7 times 1 is 7, plus 6 is 13. We add them together. And we bring it back 1, 2, 3, 4, and we get our answer to be 1.485. Excellent. Does that make sense to everybody so far? Let's see a show of hands. Thumbs up if you are getting this. I see some thumbs medium. I'll take it. Lucy has a vegetable garden that measures 16.75 feet in length and 5.8 feet in width. What is the total area of the garden? What is area when we are doing that? How do we find area? Who can tell me? Fernando? Yep. Length times width. You will be doing that forever and always. Forever and always. So our length is 16.75. Our width is 5.8. Once again, we don't line up our decimals. We line them up at the far right. We had to move it over 1, 2, but now an additional third. So it doesn't matter how many times we move it over or from what number. It still is always how many times we're going to have to move it back. So in the end, we're going to move it back 3 times. So 8 times 5, 40. 8 times 7 is 56, plus 4 makes it 60. 8 times 6 is going to be 48, plus 6 is going to be 54. 8 times 1 is 8, plus 5 is 13. We add our magic 0. 25, 35, 37, 33, and 8. So we get 0, 5, 11, 7, 9, which brings it over 1, 2, 3. So our answer is 97.15. Thumbs up if you agree. Thumbs up. We got a lot of thumbs up here. So this next one was a little bit confusing, but you will have SBAC questions like this, so that's why we're going to do it. So we have this shape. So here's the picture of the shape. It's already broken apart into 2 sections. We just need to be able to find the area of each of the 2 sections. So first of all, we know that this is equal to 6.1, right?
Yes.
And this side is equal to 3.1.
Yes.
So how much is this remaining side equal to? Who can tell me? Gore?
3.
It's equal to 3. How'd you figure that out? How'd you figure out that it's equal to 3 inches?
Because 6.1 subtract 3.1 and get 3.
Exactly. He did. 6.1 minus 3.1. We get 3.0. Exactly. So he's already solved that that's 3. Now, additionally, here at the bottom, we have 6.9. And here we have 3 inches. So how much is this area? Does it even matter? Do we need to find it out? No. It's not important.
Not important.
We already have the availability to find here. What's the length of this side and the width? Just give me the 2 numbers, length and width. Who can tell me?
3.1.
Perfect. 6.9 and 3.1. Lastly, what about the other one? What's that length and width up there? What's the length and width of the top one?
3 and 3?
Yes, Miles, it is 3 and 3. So then we just do the math. So what's the answer for the area for the top one? What's the answer for the area for the top one? Let's see, Daniel, it is 9. And what did we get as the area for the bottom one? Who can tell me? Ida, what do we get?
21.39.
Yes, 21.39. We add those 2 together and we get 30.39, and that's gonna be our area squared. So that's gonna be our area squared. We just added these 2 together because they're 2 parts of the same figure. So we already have it. Be careful with our multiplying of decimals. Okay, this one's actually a lot easier and a lot of you guys freaked out. Izzy's incredible library has 9,440 nonfiction books. She wants to split the books evenly among 80 shelves. How many books will be on each shelf? What operation are we doing here, Daniel? Division. All we're doing is we're dividing 9, 4, 4, 0 by 80. It does not go into 9. It goes into 94 once. We're left with 14. We bring down our 4, 144. It still only goes in once with 80. That's still going to bring us down to 64. We drop down our 0, and that's 8 times 640 evenly. So our number is an actual even 118. It's a pretty good inclination seeing as we're dividing a whole number by a whole number, but it's still, you could end up with decimals. But we get a nice 118 for that. So I want you guys to try these problems on your paper. So we got the first one, 20.4 divided by 3. Which number is our divisor? Who can tell me which our divisor is? The divisor is the 3. Who agrees? 20.4. It's our 20.4. What is that 3 called? Who remembers what the 3 is called? It is called what, Michelle? Dividend. And we are trying to solve for the, who knows? Quotient. Excellent. So this first one, really, really easy. In fact, the first 3 are really, really easy. The bottom one is where we might have our trouble. Okay, doing number 10. 3 goes into 2. It goes in 0 times. 3 goes into 20. It goes in 6 times. That's 18. 2. Bring our 4 down. It goes into 24. 8 times. But now here's the thing. We have to bring our decimal straight up.
It's 6.2.
So that's how our decimal works, 6.8. So we get our answer to be 6.8. Does it make sense how we just brought the decimal straight up? Let's look at the second one. 3 326.12 divided by 31. So 31 goes into 3 0 times. 31 goes into 32 1 time. By miraculous amount, it is 31. We subtract, we get 1. 16 does not go in. 161, that goes in 5 times. That is 155. We subtract that, we get 6. We bring down the 2, and it's an even 2 times. 62, 0. Now, our decimal was right there, which means our decimal just goes straight up, and it becomes 10.52. Exactly. All we do when we divide is our decimal goes straight up. Let's try it with number 12. Here, 55.2 divided by 46. I'm just immediately going to bring my decimal up because we already know to do that. 46, 0, 1, 46. That brings it to 9. 2, and I'm going to bet you, yep, it goes in 2 times, 92 at 0. So our answer is 1.2. Our decimal just goes straight up. The last one's a little different though, so I want you guys to try the last one and then bounce around your ideas to me. So who can give me an idea of what we do here? What do we think, Fernando? I get the what? Yes, I move the decimal point out of my operation. I cannot have a decimal point in my dividend. Is it okay that I have a decimal point in my divisor? Yes, but I cannot have a decimal point in my dividend. So I just move it over and I'm done, right? Yeah? I'm all good?
No!
What do I have to do then, Miles?
You have to move the decimal on the other one time.
Exactly. What I do to one, I do to the other. The decimal point is always at the end if we don't see it. I move it that way. Our new decimal point is right there. And then we simply do the division. So do it on your paper. 64. It does not go in here. It does not go in here. It does go in 1 time here. 64. We get 56 left over. 560. We bring that down. We get 8. Do you know what 64 times 8 is? Who can tell me 64 times 8? Anybody can tell me? 512, yes. When we subtract that, we end up getting 48. We now bring down our 0. 480, it goes in 7 times. So we know that 7 times 64 is 448. We do that subtraction, we get 32. Bring down the 0, and it goes in exactly 5 more times. So we get our answer for this one to be 18.75. On your paper, you'll have enough room to show the long division. On mine, I did not. But the important rule to remember is that your divisor can have a decimal, but your dividend that's the important rule to remember. The divisor, that's supposed to be an R. The divisor can have a decimal, but your dividend cannot. Miles' submarine sandwich is 1.5 feet long. He cuts it into 1/4 foot pieces. How many pieces will he have? There's 2 different ways we can go about this. We can go about it the 3rd grade way, but we're also going to go about it the 6th grade way. So, here's the 6th grade way. We have 1.5, and we're dividing it by 0.25. We move our decimal over twice. We move it over twice. How many times does 25 go into 1? 0. 25 go into 15? 0. How many times does 25 go into 150? 6. With 150, and we get 0. Here's the 3rd grade way we can do it. We know that this is 1 foot, and this is 0.5 feet. We want to cut it in 0.25 feet, which means we want to cut it in fourths. That means it would be like this. We cut it into fourths. 1/4, 1/4, 1/4, 1/4. And we get 6 pieces. So there's 2 ways to do that. I highly recommend the 6th grade way now that we're in 6th grade. Okay, now this one again. Let's try this one. So the first things first, what's our rule about dividends? What can they not have, Rafi? They can't have our decimal. So we move that over. We move that over. There's our new decimal. Now, 34 goes into 1. 0 times goes into 16. 0 times goes into 167. 4 times. 4 times 34 is 136. We subtract that, we get 31. We get 312. That goes in 9 times. 9 times 34 is 306. We get 6. 68, it goes in exactly 2 times. So, we get 0.0492. Next one, we have 8.4 divided by 0.02. Yet again, we need to move our decimals. 1, 2, 1, 2. Our new decimal goes there. This is really easy. How many times does 2 go into 8? Number of fingers. Number of fingers. Yes, we see 4. That is 8. We bring down our 4. Number of fingers. How many times does 2 go into 4? Number of fingers. Excellent. 2. It's exactly 4. Here's where a lot of you had a problem. You forgot to bring down that last 0. We have to go until that decimal point. How many times does 2 go into 0? Number of fingers? 0. So our answer becomes 420. On a separate sheet of paper, solve these 4 problems and tell me which is not like the rest. Which does not have the same quotient as the rest. That's your hint. That 3 of the 4 should have the same quotient. Let's look through. This first one should be easy. 49 divided by 7. 49 divided by 7. Who can tell me it? Let's see everyone at the same time. 7. Yeah, we know that one. What about 4.9 divided by 7? What did we get for that one? What did we get for Mario? 0.7. What do we get for this next one? 0.49 divided by 0.7. What did we get, Gore? 0.7. What about this last one? 0.049 divided by 0.07. What do you get, Miles? 0.7. So which one's different? The first one is different. So the first one is different. One thing that you can tell, here's a hint. This one, they have exactly the same dividends, but they have different divisors. So you know something's going to be different between one of those two. We only have to check it against one other to make sure that it has the same quotient. So you wouldn't even need to check all of them, and you could just look at them. But anyway, that's how we do that. Now, here's another one. A lot of you got this wrong. When we do subtraction with decimals, what do we have to do? When we do subtraction with decimals, what do we have to do, Fernando? Line up the decimals. Thank you, Fernando. But what about this one? I don't see a decimal here. What do I have to do, Daniel? I add one, so I just do plus decimal? Excellent. How do I add it, Daniel? Exactly. So I add it to be 0.00, and then I subtract 16.98. Exactly. So a lot of you forgot to line up the decimals with subtraction. A lot of you put the wrong one on the top and did the wrong subtraction. So 0, 0 does not work. We got to borrow. So this becomes 6. This becomes 10, which becomes 9, which this becomes 10. We get 2. We get 0. We get 0. We get 8. Our answer is 80.02. Excellent work, you guys. Okay, this one should not have been as hard as it was either. So we have a hat. That costs $10.95. We also have a really ugly t-shirt. It only costs $14.20 because it's really, really ugly.
That's an expensive shirt, Mom.
But then we have our nice handy dandy $50 bill that we're going to buy both of these things with. It's asking me, how much will I have left? How much will Brendan have left if I pay for both items with my $50 bill? What's the operation I'm going to be doing here? Who can tell me, Malia? Addition? That we could be doing that. Yeah. What else could we be doing here? Subtraction. So there's two different ways that we can go about this. So there's two different ways we could do it. We could do it by subtraction separately twice, or we could add the products together and then subtract them. So whichever you choose to do, just make sure you remember to do the final subtraction. Let's just go about it the double subtraction way. Here, this becomes a 4, 9, 9, 10. 10 minus 5 is 5. 9 minus 9 minus 2, we can't do that. It becomes a 19. This becomes an 8. 19 minus 9 is 10. Minus 2 is 8. We drop our decimal. 8 minus 4 is 4. 4 minus 1 is 2. We get our answer to be 24.85. It works the same way if we did it the other way. So, in this situation, we have pears. They cost 92 cents per pound. So these pears, they cost 92 cents per pound. And then we also have apples. And these apples cost $1.10 per pound. So Gloria bought 3.75 pounds of pears and 2.1 pounds of apples. So we have to see how much she spent in total. What does that word total indicate again? Who can tell me what the word total indicates? Romario. Yeah, in math. Yes, it means the answer. What were we doing to get the answer? What was our operation to get to total? Our operation for total, Rafi? Addition. So we know that by the end of it, we're going to be doing addition because we see the word total. So she bought some amount of pears and some amount of apples. How much do the pears cost? How much do the pears cost?
92 cents.
Yeah, so they cost 92 cents. And she bought 3.75 of those amount, that many pounds. What about the apples? How much do the apples cost? Jasmine says $1.10. And then she bought 2.1 pounds of that. So we're going to need to find out how much she spent for each and then combine it. Also, as a helpful trick, this ends in a 0, so just move it over. I don't want to have to move my decimal over twice. It ended in a 0. We can just pretend that 0 doesn't exist. Who has the answer for how much she spent for pears? Who has the total answer? Daniel? Perfect. She spent $3.45. Who has the total answer for how much she spent on apples, Gore? Perfect. $2.31. All we have to do is add that together. 345, 231. We get 675. So our answer is $5.76. We know that we have to do that addition in the end because they're total. And we have to find out how much she paid. And you pay per pound. Remember, per means each. So, per means... So, same thing that we do here. We just make sure we line up to the right. I always like to choose the one that has more numbers to go on the top. However, they both have the same. So, I'm just going to do 3005, 2504. I moved this one over 1, 2. I moved this one over 1, 2, 3. In the end, I'm going to move it back 5 places. So do this on your paper and then move the decimal back 5 places. If you notice, there's 4 numbers in each of these, yet I only have 3 rows. Normally, you have the same amount of rows as you have numbers in a problem. But when you have a 0, it's just going to be an entire row of zeros, so we can just skip it. It was the second one, so instead of 1 magic 0, I added 2 magic zeros. Anyway, we get this. We add it all together. We get 75.2452. It's got a 0. It doesn't matter. Last problem. We have 0.6, and then we add 0.0024. The only important thing is we need to move our decimal place out of our dividend. How many times are we going to be moving that decimal place then? Who can tell me, Daniel? 4. We move it. 1, 2, 3, 4. We do the same on this side. 1, 2, 3, 4. Excellent. So that's where our decimal is. Let's do it together. 24 goes into this. It goes into 60 twice. That is 48. That is 12. 120, it goes in 4 times. That's 120. And then here it goes in 0 times. So we get our answer of, oh, it goes in 5 times because I'm being dumb. It goes in 5 times, and we get our answer of 250. Excellent work. Today we will be reviewing Chapter 4. Chapter 4, we're mostly dealing with multiplying and dividing fractions, whole numbers, and mixed numbers. So let's start these two on a separate sheet of paper. If you can't see them, we've got 3/5 times 4, and we've got 2/5 times 7. So I want you to do this on your notes and tell me what you get as your answer when I call on you. So Raphael, how do we know that we do 3 times 4? How do we know that? So he says we add 1 to the denominator. That's correct. When we add 1 to a denominator, does it change anything? No. So then, how do we know which ones to multiply? What do we multiply? Who can tell me? Let's see, Fernando. Yeah, we multiply across. So, what we get for here is 3 times 4. Everyone, 3 times 4 is?
12.
Everybody, 5 times 1 is?
5.
Is this our answer?
No.
Okay, let's see. What do I have to do, Alinza? So yes, Gohar, we have to simplify it. So, first of all, how many 5s fit in 12 without going over? Show me number of fingers. Number of fingers. Perfect. So 2 5s go into it. And how much is left over? How much is left over? Fingers? Once again, 2. And we keep our denominator. So our answer is 2 and 2/5. For that second one, we do the same thing. Add 1 as our denominator and multiply across. 2 times 7 is 14 over 5. In this case, we get 2 and 4/5. Exactly. We're going to look at number 3 now. So, the Mississippi River is the second longest river in the U.S., with the Missouri River being the longest. The Mississippi River is 23/25 the length of the Missouri River. If the Missouri River is 2,540 miles long, how long is the Mississippi River? How do I set this problem up? Who can tell me how I set this problem up? Remember, we're dealing a lot with multiplication, division, stuff like that. Is this a multiplication problem or a division problem? What do we think? Raise our hands for multiplication. Raise our hands for division. It's actually multiplication problem. So, how do I set this problem up? Who can tell me how I set it up? Hannah nailed it. We take our 23 over 25. We multiply it by 2,540 over 1. Now, to make our lives easier, is there anything that we can do here before we start, Trey?
Multiply by 20.
No, that is not what we can do. What can we do, Hannah?
You can cross-cancel.
We can cross-cancel. What do you think we want to cross-cancel by? We can't cross-cancel 23 and 1. That's already simplified. What can we cancel by, Elsie? 5. That sounds great. 25 divided by 5 is 5. So, for this one, I like to split it up. 2,540. 40 divided by 5 is what? Who can tell me? 8. 500 divided by 5 is what? 100. 2,000 divided by 5 is what? 400. We add it together, we get 508. Then, all we do is we multiply across. So when we multiply 23 by 508, we get 11,684. Is that our answer?
No.
And we know that's not our answer because we know the Mississippi River is shorter than the Missouri. So our answer should be shorter than 2,540. What is the last step we need to do? What do we need to do, Daniel? Put it over 5 and divide. I know Trey was going to say the same thing, so let's do that. So So when we do our long division, we get 2,336.8. Notice we had to add a decimal and we lined it up. We had to add that decimal, line it up, and exactly, we get this number exactly. Does this number make sense that the Missouri River is bigger and it's 2,540 and the Mississippi is smaller and it's 2,336.8? Does that make sense? Yes, because we know it's smaller. So our answer is 2,336.8 or 2,336 and 4/5. Same exact answer. Really quickly, these are exactly like numbers 1 and 2, but probably even easier. So I want you guys to solve these. So this first one, 2/3 times 5/7. Can we cross cancel anything?
Yes.
What can we cross cancel?
A 5.
Nothing, we can't. So 2/5 times 3/7. What do we get as our answer here, our initial answer, Trey?
6/35.
Perfect. Can I cancel anything out? Can I simplify?
No.
No. We already know that since we couldn't simplify earlier, we can't simplify later. Exactly. Now our next problem. We have 3/5 times 5/7. Am I able to cancel anything? What can I cancel out, Liam? The 5 and the 5. Boom, boom, they're gone. I get 3 times 1 over 1 times 7. I get 3/7. Super easy peasy lemon squeezy. Next one. Miss Diaz had 7/8 of her class present. And 1/2 of those present were wearing pants. What fraction of the students total were wearing pants? The students total were wearing pants. Michelle, what do I do here? 7/8 times 1/2. Exactly. Because 7/8 of my students showed up and half of them were wearing pants. So we just multiply across. Can I cross cancel anything? Nope. So I get 7/16. Can I simplify? That's it. That's our answer, 7/16. So next one. I have 3 3/5 times 5/12. What do I do here first? What's my first step that I do here? Jaden, what do I do? So we don't multiply the two big numbers together. What do we do, Madison?
You make, so basically you multiply, for the first one you multiply 3 by 5 and then add the 3.
And we add what we get to that. So that's called making it into a what, Nathan?
Mixed fraction.
Not a mixed fraction. What is it called, Malia? Improper fraction. 3 times 5 is 15 plus 3 is 18. We get 18/5. Let's do the same for the other one. 5 times 12. Who can tell me 5 times 12? Anita. We get 60 plus 5. We get 65/12. Hey, can we cross cancel anything, Nathan?
Yeah.
What can we cross cancel?
The 5 and the 65.
5 and the 65. It becomes 1
And 13.
and 13. Can we cross cancel anything else?
Yes.
What else can I cross cancel, Daniel? 18 and 12. I cancel it by 6. It becomes 2 and 3. Exactly. What's 3 times 13? Who can tell me?
39.
Rafi? 39. 1 times 2 is 2. How many 2's go into 39? How many 2's go into 39 without going over? How many 2's go into it without going over? Let's see, Daniel. 19, and we have 1/2 left over. Exactly. Now that we've gone through this one together, I want you to do this one.
Okay.
Now, is this the proper setup? 4 times 2 and 1/2 times 5/6?
No.
So then I get 8 and I get 5/12. Is that the proper answer? No, I can't do that. I have to make it into an improper fraction first. I have to. Waldo, what do I do first? I turn it into an improper fraction. So what is 4 and 1/2 as an improper fraction? Yes, Oswaldo, we get, oops, I'm erasing, 9/2. What about 2 6/5 as an improper fraction, Romario? 2 6/5 as an improper fraction. 17/6. Can I cross cancel anything?
Yes.
What can I cross cancel, Liam?
The 2 and 17.
So how do I cross cancel 2 and 17? Can I do that? No, 17's odd. What can I cross cancel, Anita? 9 and 6. Their greatest common factor is what, Trey? What's the greatest common factor? 3. So this becomes 3 and this becomes 2. What's 3 times 17, Trey?
3 times
51 over 2 times 2 is 4. How many times does 4 go into 51 without going over, Michelle? 12. And what's left over? 3/4. Excellent. Claude Monet's painting, Seaside at On Floor, on display at LACMA, by the way, measures 59 7/10 by 81 3/10 centimeters. What is the area of the painting? Again, how do I find area? Who can tell me, Michelle? Length times width. Exactly. Our length is 59 7/10, and then our width is 81 3/10. If you ask which one's which, it doesn't matter. They're the same thing. Either one can be length or width. But what do we need to do to these numbers, Miles?
You need to make them a improper fraction.
Exactly. We need to make them an improper fraction. This one should be really easy to do, by the way.
Yeah.
Jasmine, what is 59 7/10 as an improper fraction? 597 over 10. What is the next one, Oswaldo? Perfect, 813 tenths. Now, I know I can't cross cancel anything because neither are divisible by 2, 5, or 10. So I simply have to multiply across. All I know is at the bottom, I'm going to get 100. At the top, let's do that together. When we multiply, this is what we get. We get 485,361 over 100. Who remembers my trick to solve this problem easier than dividing by 100? Trey. Yes, Trey, we put the decimal at the end and we want to get it over 1 because anything over 1 is our answer. We move it over twice. What we do to the bottom, we do to the top. We move it over twice and we get as our answer 4,853.61. I also just want to show you guys, this is the painting. Look at how beautiful this painting is. It's a real painting. Liana ran 17,160 feet in a day. How many miles did she run? So, now, she ran 17,160. We're going to want to divide it by something because we're splitting it up from feet into miles. How many feet are in 1 mile? How many feet are in 1 mile? Let's see, Oswaldo. Yes, 5,280. Exactly. We can just do our long division, but quite frankly, I don't want to. So, who has the answer? If we did the long division, one other way is that we can just continually add 5,280 until we go over, but we get 3 1/4. Remember, I always make them work out pretty nicely. We get 3 1/4. Okay, next side. We have 6 divided by 2/3. What do we need to do when we're doing a division problem? What do we need to do? Let's see. I want to call on somebody new. Elsie.
You keep the first number the same, you turn division into multiplication, and then your reciprocal.
Exactly. We find the reciprocal. Keep, change, flip. So 6 is 6 over 1. Change becomes multiply, and the reciprocal is the flip, the reciprocal, 3 over 2. What is 6 times 3? Actually, we could cross cancel if we wanted. Let's cross cancel. We get 1 and we get 3. What's 3 times 3? 9 over 1 is just 9. As such, here, 8 times what equals 1? First of all, 8 over what equals 1? Madison.
8 over 1.
8 over 1 does not equal 1. 8 over what equals 1, Jaden? 8 over 8, which means that if we multiplied 8 by 1/8, we would get 1. That's the reciprocal. The reciprocal of a number is when you multiply it by the first number and get 1. When you multiply it by the first number and get 1. So, Gore owns 4 acres of land that he wants to split into 2/3 acre lots. How many lots will Gore have? Who can set up this problem for me? Who can set it up, Elsie? 4 divided by 2/3. Exactly. We do our Kentucky chicken fried, our keep, change, flip. We get 4 over 1 times 3 over 2. We can cross cancel. What do I get as my answer? 6.
Can you wait a little bit?
As such, do this one in your books. Okay, Brendan, what do we do for this problem? So, what do we do, Sophie, as your lifeline? Perfect. So we do our keep, change, flip, our Kentucky chicken fried. So, which fraction do we keep? What fraction do we keep, Sophie or Stephanie? First one, 1/5. What do we change, Olivia? Division to multiplication. And which one do we flip, Em?
5 7 until 7/5.
Excellent. Now, can I cross cancel it all? No, because I can't do that. So we multiply, and what do we get as our answer? We multiply across, Angel. Yes, 7 over 25. Perfect. We get 7 over 25. Let's look at the second one. I want to call on Caesar. What do we do here, Caesar? Keep, change, flip. Same thing. So it becomes 2/5 times 4/3. Can I cross cancel anything? No. So I multiply across. What do I get, Angelo?
So the 8 and 15.
Perfect. 8 over 15. Can I simplify?
No.
Nope, that's it. I get 8 over 15. Now it gets a little trickier. Emmett, what do I have to do here?
So you multiply the 6 in the denominator?
What exactly? What am I doing? What is that called? It's not keep, change, flip. What am I doing in this situation, Ani? Exactly, making it into an improper fraction. So Emmett's correct. We multiply the 6 times the 2, the denominator, and add it to our numerator. So what is the improper fraction version of the mixed number 6.5? Izzy? So what's the improper fraction version? Let's see. I want to call in Olivia. 13 over 2. Excellent. Then we do the change to multiplication. Now we still need to make it into an improper fraction. Let's see, Sophia, what is this next one is an improper fraction? Exactly. So when we do our flip, it's 4 over 13. So Sophia was correct. She already did the flip as well. What can I do now? Can I do something now? Let's see, Shiley. Perfect. Cross cancel 13, 13. It becomes 1 and 1. What else can I do, Leanne? 4 and 2. It becomes 1 and 2. What do I get as my lovely answer here? Let's see a new hand. I want to see a new hand. Let's see. Amari. Perfect. I get 2 over 1, which is just 2. Excellent. Last problem. Same sort of thing. We have to turn it into a improper fraction. So, Eurene, what does 4 and 2/3 become as an improper fraction? Perfect. 14 over 3. I do my change. First of all, what is 2 and 2/9 as an improper fraction? What is 2 and 2/9 as an improper fraction, Chris?
29.
It is not 20, or it is 29ths. It is 29ths. But that's it originally. So now what do I have to do, Ani? Flip it. Exactly. Can I cross cancel anything, Emmett?
Yes.
What can I cross cancel?
3 and 9.
3 and the 9. It becomes a 3 and a 1. Can I cross cancel anything else? What else can I cross cancel then, Kyle? Emmett, what else? 14, 20. What does it become when I cancel it, Izzy? 7 and 10. Excellent. So what do I get as my answer here? Who can tell me what my answer is, Dominic? Perfect, Dominic. We get 21 over 10. Is that my answer? No. What do I have to do, Leanne? Simplify. What do I get when I simplify, Jaden? Perfect. It's 2 and 1/10. Excellent. He saw that 10 goes into 20 2 times without going over, and we're left with 1/10. Excellent. So, how many 3/8 pound bags of trail mix can Sophia make from a 6 3/8 pound container of trail mix? So, what is the operation that we're doing here? Addition, subtraction, multiplication, division. What's the operation that we're doing here? What do we think, Stephanie? So we're going to be doing division. We know because we are splitting our trail mix into other bags. So we are dividing. What are we dividing by what? Tell me, what are we dividing by what, Kyle? That's a good guess, but that is incorrect. Yes. Perfect. 6 3/8 divided into 3/8 because we want to turn our whole, the bag that we have, into the different parts. So, first we have to do our keep, change, flip. Let's make it into a mixed number. We already know it's going to be times 8 over 3, and it's going to be something over 8. What's 6 times 8? 6 times 8. Let's see, Urine. 48 plus 3, Olivia? 51. Let's see. Can I cross cancel anything? This should be pretty easy. What can I cross cancel, Marcus? The 8 and the 8. Boom, boom. They go away. Can I cross cancel anything else? Justin says he thinks so. He's correct. What can we cross cancel? Yes, so it becomes 17 and 1. So then what would our answer be? What's our answer? Ani? 17. That's it. Super easy. What you're going to do is on the test, it said circle the mistake, use words to explain the mistake, and fix the mistake and solve. All I want you to do is fix or just solve the initial problem, okay? So, in this case, this part, the first part, is always correct. That's never the mistake. So, I want you to start with that first part and solve. Okay, let's see, Victoria, what do I do? We multiply. How do we multiply it?
You multiply 2 times 1.
Perfect. 2 times 1, we get 2. And then what else do we multiply?
3 and 4.
So we get 12. Is that our answer?
No.
I have to simplify it. Jaden, what do I get when I simplify?
1/6.
1/6. Exactly. Who can tell me what the mistake I made here was, Izzy?
They multiply the top and they multiply the bottom.
So what is the mistake then, Caesar?
You try to keep, change, flip.
I did an accidental flip here. I didn't need to do the reciprocal. That's not what I needed to do. Okay, next problem. We have 3/4 divided by 2/3. So I want you guys to solve that correctly. Okay, Brendan, what do I have to do here? So I have to keep, change, flip. So it becomes, I keep doing that. It becomes 3/4. The change is times, and then it's 3 over 2. Can I cross cancel anything? No. So we just multiply across. It becomes 9 over 8. 9 over 8 simplifies to what, Emmett? 1 1/8. Excellent. What was the mistake I made in this problem? Ani?
For the 1/2 divided by 1/1, you have to multiply.
What's the main mistake, Izzy?
You forgot to flip.
I did forget to flip.
And you forgot to change.
What else did I do, Olivia? Exactly. I cross-canceled. I can't cross-cancel unless it's multiplication. Otherwise, this was a cross-canceling. That was the mistake that I made initially. Exactly. Last problem. So, I want you guys to solve this one and keep in mind the mistake that I made in the problem. So let's go step by step. Marcus, what's the first step I have to do? Make it into an improper fraction. Exactly. So, what is 6 3/5 as an improper fraction, Bree? It's 33/5. Exactly. I'm dividing it. What is 2 3/4 as an improper fraction, Caesar?
11/4.
It's what? 11/4. Exactly. But now I have to do my keep, change, flip. So it becomes 33/5 times 4/11. Can I cross-cancel anything? Can I cross-cancel anything? What can I cross-cancel, Shiley? Perfect. It becomes 1 and 3. What do I get as my final answer right now, Sean? 12/5. What is 12/5 simplified to, Sophia? 2 and 2/5. That's our answer. What is the problem that I made? What was the mistake that I made, Chris? Exactly. I flipped the wrong fraction. I did flip, change, keep. That's not how it is. It's keep, change, flip. That's why I got it wrong. Excellent job. Thank you. So we're going to begin our last chapter, the chapter 5 review. So chapter 5, what we're working with on chapter 5 is mostly number value, number operations, understanding numbers. You think we would have gone over this in chapter 1, but here we are now. So our first question is to graph these on a number line. So I want you to make 3 number lines and we're going to graph them. Take your time. There's 3 different, A, B, and C. Graph each one on their own number line. Okay, Romario, graph 1A for me.
Oh.
Romario is still graphing. Go ahead, Romario. Keep going.
Bye.
Is she graphing?
Yeah, and that's pretty much it.
Excellent. So now you have to plot the points.
Wait. Oh, okay. Like circle it?
Yeah, you just put a dot where it is on the number line.
What the heck?
Just, yeah. Just touch it once. And then. Perfect. Who agrees with him? Thumbs up. Awesome. Everybody should. It's correct. Hannah's graphing our second number line.
Hi, Hannah. Hi. No hide back.
Be like that.
Oh, this one here.
Oh, hold on. You're using the big one, but it's okay.
Oh.
There you go. Keep going with the thin one. Go ahead.
Oh, wait.
Now I'll have you plot your points. Okay. There you go. So she's plotting her points now.
Okay, that didn't function.
I'm gonna pause it so I'm giving you time. Perfect. So Hannah did this perfectly. We initially had a small mistake, but she looked back and fixed it, and now we have it graphed perfectly. Thank you so much, Hannah. Now I want to invite Fernando up to do number C. So Fernando's going to be graphing C.
I'm in
Excellent. So Fernando set up his number line, and now he's going to graph the points. Just tap, yeah. Excellent. Do we agree with him?
Yeah.
Yes, great job. So what do we notice about Romario and Hannah's number line? What do we notice about their number lines? Let's see, Rafi.
Fernando doesn't have a 0.
Yeah, so exactly. Hannah and Romario's both have a 0 in their number line. Fernando's doesn't. Does that mean Fernando's wrong? No. You can start a number line anywhere on the number line. The one rule is that the spacing between each number has to be the same. Had somebody done a spacing where they did 1, 0, -3. Doesn't work like that. Can't do it. Illegal. You will go to jail. No. Our next problem should be very easy. Solve the absolute value. Before we start, who can tell me a fact about absolute values? Miles?
If it's like negative, but it's inside the 2 lines, it'll still be the positive.
So if it's inside the 2 lines, our answer is always positive. Exactly what Miles said. If it's inside the 2 lines, our answer is always positive. So for absolute value of 25, what's the answer? Raise our hands.
25.
Gore. 25. It's not -25 because it's still it comes out positive. What about -14, Liam?
14, it would be 14.
14. Perfect. Now, Gloria, what about -20 minus 17?
3.
We get 3 because we get -20 becomes 20 minus, it stays 17. We get 3. Here's a tricky one. Let's see. I want to see Lucy. What is negative absolute value of -5? -5. But what? I thought all absolute values were positive. What is this, Hannah?
That only happens if the shape is on the inside.
Exactly. It only happens to what's on the inside. Whatever's on the outside doesn't matter. That gets applied later. Now, absolute value of 1 minus 2. First of all, what is 1 minus 2? What is 1 minus 2? Let's see, Romario. 1 minus 2 is not 1, but we are close. Malia? -1. So this absolute value becomes the absolute value of -1. What's the answer? 1. And then lastly, and this one should have been easy, absolute value of 31 plus the absolute value of -31. What is that answer? Who can tell me? Let's see, Trey.
62.
Yes, 62. Exactly. Everybody should be able to get these. Whatever comes out of an absolute value is always positive, but it can be impacted by whatever comes beforehand. So for example, I just want to show us a trickier example that you might see later. What is the answer to this problem? I'm going to give you guys a chance to think about it, and then I want to hear your answer. So, Rafi, what's the answer? Not -5. That's another good guess. What's the answer, Michelle? 14. Lucy had it too. So, Michelle, how did you get 14 as your answer?
Because the absolute value of -7 is 7. And then it would be 2 and 7. But if there's no symbol, then you have to multiply.
Exactly. If there's no symbol, if something is just touching, just like we know with our parentheses, what we know with our distribution, if it's just touching, it's multiplication. So we get our answer to be 14. So what we're doing is we're trying to solve the inequalities. So go ahead, Liam, and you can solve them.
All right, spin. So that, like that.
Okay, so let's see. Do we agree with the first one?
Yes.
Yes. So we agree with this one? We agree? Yeah, we should. Do we agree with the second one? Yes. Do we agree with this third one? No. Do we agree with the fourth one? Yes. So I'm going to have Daniel come up and, well, actually, it's really easy. The other one, when we flip it, it is to this side. Daniel, why is it to that side?
Because it turns positive and 19 is bigger than 13.
Exactly. In the absolute value, it turns positive, so 19 is bigger than 13. Exactly, guys. So we order from least to greatest. A couple of you ordered from greatest to least, which is just embarrassing. Okay, let's go through this. Which one is the least? Who can tell me which one is the least? Jaden.
Negative 79.
Perfect. Negative 79. Which one comes next, Miles?
Negative 55.
Negative 55. Which one comes next, Nathan?
Negative 10. I mean 10.
There is no 10. There is no 10.
So what is that?
But Nathan, yes, 18 comes next. Gloria, what comes next? 44. What comes next? Let's see, Emerson. 101. And then what comes last, Trey?
143.
143. Exactly. Don't worry if I saw on your test that you had put 10. I adjusted because technically you were following what you believed to be was least to greatest. So that's okay. But pay attention. Next problem. Write each fraction as a decimal. So we're going to write each fraction as a decimal. How do we go from fraction to decimal again? Who can tell me? What do I do? Daniel? Long divide. And use bar notation if needed. What does bar notation mean? What does bar notation mean, Michelle?
It's when it's a repeating decimal and you put the little bar.
Exactly, it's when it's a repeating decimal. For example, 33.3, that goes on forever. We say this because that's equal to 1/3. So we put the repeating decimal over that. So I want you guys to solve this problem first. Okay, let's start, Madison. I want you to solve this problem. There's 2 parts. Go ahead.
Okay. So we have to divide, right? Yeah. So we have to divide.
We have to divide, exactly.
Wait, which one goes where? I'm so confused.
So Madison's continuing. She's doing her long division. Go ahead, Madison.
You want me to speak?
You can speak, you cannot. Whatever makes you comfortable.
I won't speak. What? Okay. This is a 0. It looks like a potato.
So what are we noticing, Madison? It's repeating, right? So what kind of decimal is it? You can just put an R if you don't want to. We can do that. Excellent. So we get that as our answer. Now, there was a negative in front of it, so all it becomes is negative 0.2 with a bar notation over it. Excellent. Rafi, come on up here for B. So, Rafi, do our division.
Wait, how do I erase this? It's so big. Oh, wait, no. Erase it. Like that?
Yeah, so he's going like this. Perfect. He made it into an improper fraction, and now he's doing his division. Great job.
No. 5 does not fit into 4.
He's doing a great job so far.
0.
So, we did this. Now, there's only one problem here. Can anybody notice the one problem that he did? What's the one problem? Let's see. Hannah, what's the problem?
You're supposed to divide 4 by 5.
Yes, we're supposed to divide 4 by 5 because it becomes 5 divided into 4 groups. So it's 5 divided into 4 groups. But I'm going to show you how to solve this 2 different ways. So the first way, we have 5 divided into 4 groups. 4 goes into 5 one time. 4 minus, we get 1. We bring our decimal. How many times does 4 go into 10? Number of fingers? 2. That is 8. We get 2. We bring this down. Number of fingers. How many times does 4 go into 20? 5 times. That's 20. We end. We get our answer to be 1.25. Let's look at this trick method. We already know that there's going to be a 1 because it's already 1 and something. So it's going to be 1 point something. At this point, all we need to do is divide 1 into 4 parts. It becomes, we have the whole 0, then it's 10, then it's 2, and then we do the same thing, 2, 0, 5. So once again, it becomes 1.25. We already knew that with the 1. That'll help us with letter E. Is this repeating or terminating? Terminating because it does not continue. Okay, Gore, come up for number 3. Okay, Gore, begin. Perfect so far. What do we notice here? Exactly. Perfect. Is this repeating, Gore, or terminating?
Repeating.
It's repeating. We get 0.4 with our bar notation over. Next, I want Michelle to come on up. This one's a bit long. Michelle did this, and really quickly, actually. So what we notice is that it goes pretty long. But as I pointed out before, here's a 60 minus 56. There's a 60 minus 56. That means our problem is going to keep repeating. So we get as our answer this really long thing. 0.85714 with bar notation, and it is repeating. Okay, Nathan, come on up for this one. Nathan, begin this problem. So he made it into an improper fraction, and now he's going to do the division.
No, I messed up.
So he noticed he messed up. Go ahead, continue.
Oh, now I'm choking. Can I see my answer on that? Can I see my answer on that?
So he got 2.4. Is that terminating or repeating, Nathan?
Terminating.
Terminating, exactly. Once again, the quick way we could have done it is know that it's going to start with a 2 because it's bigger than 100. And then we divide 2 into 5 groups. We get 0. We get 4. 2.4, and it is terminating. Excellent. For this problem, we're going to label each plot point as an ordered pair. Remember with our ordered pair, what comes first? What comes first, Hannah? X comes first and then Y. Alphabetical order. Exactly. Anita, where is point A located? So what do we get for A? So what do we get, Hannah?
You get 2, 3.
2, 3. We go forwards 2. We go up 3. Okay. Point B. Point B, Gloria.
Wait. -2 and
-2, -6. We went over 2. We went down 6. Okay. Lastly, for point C, Carmen. -3, 4. Exactly. We went over 3 and then up 4. Great job. Now, the last part of this. What quadrants are they each in? What quadrant is A in? Who can tell me what quadrant A is in?
1.
Let's see, Nathan.
1.
A is in quadrant 1. What about B? What is B in, Elsie? 3. And what is quadrant C in, or what is C in? Let's see, Hannah. 2. Exactly, guys. Perfect work today. Thank you. I want everybody to write these down in their notebooks, and I want you to solve them. Like I pointed out, many people got it wrong because they didn't notice the negative signs. The negative signs impact something because, for instance, what's bigger -1 or -2? Who can tell me which is bigger? Let's see, Joey. -1 is bigger. Normally, 2 is bigger, but because it's negative, it's the opposite. So I want you to write these down and try them out. So one of the issues that we're having with this problem, the problem is that people don't know how to match them. So here in a lot of them, we have both fractions and decimals. Fraction, decimal. So not for all of them, but for most of them. The easiest thing to do, by the way, is to turn your decimal into a fraction if you know it. If not, you do long division to turn your fraction into a decimal. So let's think of this first one. -8 and 2/5, right? Let's see. Here we've got -8.3. What is 0.3 as a fraction? Who can tell me what 0.3 as a fraction is? Chase? 3/10. Now, that's still hard to see because I've got 2/5 and 3/10. I need to make them over the same denominator. How can I get 2/5 to be on the same denominator as 3/10? What else can I do, Shiley? Divide? No, not divide. What can I do, Chase? Multiply times 2. 5 times 2 becomes 10. And then this becomes 4. Now, a lot of you guys were eager beavers and you think, oh, 4 is bigger than 3. Great. But they're negative. So, who can tell me which one's bigger? -8 and 4/10 or -8 and 3/10? Who can tell me, Emmett?
-8 and 3/10.
Excellent. That one is bigger. So as such, I want you to do the same for the rest of them. Keep going. So let's see. We're going to start from bottom to top. Chris, what's the answer for F? What'd you get? That they're equal. Exactly. We know that because -3.25, 0.25 is 25 over 100, which simplifies to 1/4. Again, if we divided 1 into 4 groups, we would get 0.25. So we find out that they're equal. Excellent. Izzy, what did you get for letter E?
I got the 3.25 as much as like that one.
The first one or the second one? Which one? So you think this one's bigger? So let's see who agrees with her. Thumbs up, thumbs down. Thumbs up if you agree. Thumbs down if you don't agree. So we're seeing a mix. Let's see what it is. When we have this continued, when we have the bar notation, it means it keeps going. 5, 5, 5, 5, 5. Is that going to be, because it's a negative, more or less than 3.25, Shiley? It is going to be less because it's negative. Once again, she would have been correct had it been positive, which is why these are so tricky. Okay, let's see. Sean, for D, what did you get?
Well, I'm still doing it.
We're going to do it together. The easiest way to do this one is to make the 2/7 into a decimal. We simply divide 2 into 7 groups. 0, 2, 8. Hey, but look already. We didn't even really have to do much. We found out that our first number started with a 2 and this one starts with a 3, but they're negative. So which one is bigger? Who can tell me? Emmett.
-9 to 7.
Excellent. We already got that 2. That's smaller than that 3, but because they're negative, it's reversed. Exactly. Okay, let's see. Jaden, for C, what did you get?
5 1/5 is bigger.
5 1/5 is bigger. Thumbs up if you agree, thumbs down if you don't agree. We see some agree with Jaden, we see some don't. Shiley, Sean, why do you not agree with Jaden, Sean? Caesar.
Because making 5 1/5 because making 5 1/5 into a decimal would be 5.2.
Excellent. It matches. We would get 5.2. Again, if we made the 5.2 into a fraction, we get negative 5 and 2/10, which simplifies to negative 5 and 1/5. So these two are equal. Excellent. Dominic, let's do this last one. So what did you get, Dominic? So we're going to do this together. You better be taking these notes, everybody. So we already have 1 as a decimal, and that's going to be pretty hard to make as a fraction, especially with that bar notation. So let's just make the other into a decimal. We've got negative 4.7 bar notation, and then we've got negative 4 and 4/5. We're going to divide. 4 divided by 5, 0, 8. So we get negative 4.7 forever and negative 4.8. Which number is the bigger number, Dominic? Perfect. The negative 4.7 continuing on forever. Exactly, because it's closer to our 0 on our number line. Great job with this, everybody. To make it so you don't have to draw the graph, we're just going to graph it together. Okay, D, negative 3, 2. Okay, negative 3, 2. Am I going to go up or down or left and right first? Who can tell me up or down, left and right? Shiley? Excellent. She said because the middle one, the one that's across the horizontal, is the x-axis. We're going to go left, right first. Negative 3, which direction do we go? Left or right, Emily? Left. So we go to this negative 3. Then 2. Now we go to the other axis. Up or down, Emmett? Up. We go to that 2. We meet, and our point of D is right there. Excellent. As such, we do the same for the others. E's negative 5, negative 5. They meet right there. And F is 4, negative 1. It meets right there. So when we do this, we always go X, Y. Pay attention to that, okay? Now, here's what it's going to ask you. What quadrants are these all in? So first of all, I want you to write down these points. We're going to look at point A, B, C, D, E, and F. So look at this on your paper and write down the quadrants first. So A, B, and C, and D, E, and F. A, B, C, write down what the quadrants are for A, for B, for C, and then for D, for E, for F. Shiley, what quadrant is A in?
A is in the
Quadrant number 1, exactly. What about B, Chase? Quadrant 3. What about C, Izzy? Quadrant 4? Not quadrant 4, that's a good guess. What is it, Izzy? 2. Excellent. Let's go back and look at D, E, and F. What quadrant is D in, Emmett? 2. What quadrant is E in, Shiley? 3. And what quadrant is F in, Brendan?
4.
4. Exactly. As we know, the way that our quadrants work is it actually goes counterclockwise. We start here and we go around. 1, 2, 3, 4. In quadrant 1, both values are positive. In quadrant 2, X is negative, Y is positive. Quadrant 3, both negative. In quadrant 4, we get positive, negative. So this might be something you would want to write down because it's kind of good knowledge to have. So if negative 3, 2 is reflected about the x-axis, the new ordered pair is what? So what happens when you reflect across the axis? What is a rule you have to follow, Izzy?
The rule that you have to follow is when you reflect across like the x-axis, the x number will, I think, stay the same, and then the other one will flip.
Exactly, she's correct. When you flip across whatever axis, that value stays the same. So since we're flipping across the x-axis, Shiley, which one stays the same? Negative 3. And what happens to that other one? What happens, Emmett?
It becomes a negative.
Yeah. Changes. Becomes a negative 2. It just changes. As such, the last one that we're going to look at is if 5, negative 4 is rotated about the y-axis. The new ordered pair is what? I want to see. Justin, can you tell me the ordered pair?
Y negative 5 negative.
Perfect. We get negative 5, negative 4. Because in this case, the y value stayed the same and our x became the opposite. It became the opposite, which is negative and or positive. So for example, if we had this point, if we had negative 3, 2, and we reflected about the y, what would our new point be? Who can tell me? Shiley?
It would be 3, 2.
3, 2. Exactly. It doesn't always have to be both negative, doesn't always have to be both positive. Whatever it is, whichever axis you are flipping it about, it stays the same and the other one becomes the opposite. Excellent job, you guys. Perfect.